Beautiful. Cool. Okay, let's get started then. Welcome, everyone. My name is Tobias Ternström, and I'm a program manager in the database systems team at Microsoft. And with me, I have my buddy Travis Wright, who does the same thing, only he is slightly better looking.
We are highly redundant because, well, we're SQL, right? So we have two people that do the exact same job.
Yes, yes. Yeah, Travis does the night shift.
I'm primary, though, just to be clear. He's redundant.
Yes, thank you. Thank you. So after this great start, we're going to or attempt to do a deep dive on what we've done in SQL Server 2017. There'll be a lot of focus on the kind of multi-OS support, but as well as some other features that we've added to this release. So, Travis, can you start by just giving us an overview? What's cool in SQL Server 2017?
Yeah, absolutely. So SQL Server 2017, just a few kind of top-level points here, right? One is that as we evolve SQL Server, it becomes the database that you can use to store any type of data that you want. You can run it on any platform, and you can use any programming language to interact with it. It's also one of the leading performance databases in the industry, right? So we have set #1 TPC-H benchmarks across the board for all the different sizes for non-clustered. In terms of security, SQL Server is the leader. We have the fewest number of reported vulnerabilities according to the National Institute of Science and Technology for the last 7 years out of all the major database vendors. You can use SQL Server to power your machine learning and AI by using R and Python scripts in database. And so this is the only database that can do this on the industry right now. And lastly, we deliver all this value to you at 1/10 of the cost of Oracle. So depending upon what you sort of put together in terms of what package you want to run, you can run SQL Server at about 1/10 of the cost of Oracle. Now, with SQL Server 2017, we're introducing a new set of options for you. We're giving you the flexibility to run SQL Server on Linux and on Docker containers. And this is, of course, the first time we've ever released SQL Server on Linux. What do you guys think? Is it pretty awesome? Woo! So Scott Guthrie just said yesterday that we GA'd SQL Server 2017. It's a little tricky, though, because of the timing. We always GA on the first of a month, typically. And so we had to announce it yesterday, but the bits will be available on next Monday, 10/2. So go and get the RC bits right now if you want to start playing around with it, or you can wait until Monday and go grab the GA bits.
And it's not that it's difficult to have the bits ready at a certain date. We can only put apparently software on the price list first weekday of the month.
Right. It's complicated, I'm telling you. It's Microsoft releasing software, it's complicated.
So we work in engineering, and then we have Ramnik over here from marketing. So he's been sitting with the price list and trying to get it in there, and it's really, really difficult.
Yes, he has to put the paper through the slot. It's a very small slot, it's difficult. Okay, so we're going to provide SQL Server on 3 primary Linux distributions, on SLES, on RHEL, and on Ubuntu. And then for Docker containers, we provide an image, which is Ubuntu-based and available on Docker Hub. And you can just go and grab that image. It's super easy to get. We've actually had over 2 million pulls of our Docker image in the 10 months that it's been publicly available. Pretty awesome. And of course, we will continue to support SQL Server running on Windows, right? So now you just have some additional options in terms of where you run your SQL Server instances. Now, one thing you have to know about Tobias is that he begins every meeting with, what are the principles of what we're trying to do? Every meeting. I love this about Tobias, right? Because he makes sure that we're always on track. So, Tobias, why don't you tell us about some of the principles we had for bringing SQL Server to Linux?
I love you too, Travis. Yeah. Travis just wants to, can we just ship the software? No, so it was interesting when we started this journey with SQL Server on Linux. Like, what is the software for? And when can we ship, right? And that was actually, it was interesting when we started kind of the journey to just, decide if we can do the project and so on. That was one of the main concerns from kind of the Microsoft leadership is, if you're delivering SQL Server on Linux, will it actually be, as good as on Windows? Because if it's not, then, should we really do it, right? If it's some handicapped SQL Server on Linux, then is it really worth it, right? Because then it becomes this very, very awkward and weird thing. So the principles were fairly simple. First, we have to be on par, at least, with the performance of SQL Server on Windows, right? Apps have to work, meaning if I have an app running against SQL Server on Windows, I should be able to just move the database over to Linux, point the app at it, and it should just work, okay? Move it back and forth. And we'll show some examples of that today. And the other one is we have a whole new kind of user or persona with regards to SQL Server on Linux, which is the kind of Linux sysadmin. And it was interesting. When we first announced that we're going to Linux, there was like huge activity on Twitter with what kind of installation experience will it be on Linux? Will Microsoft have some weird GUI thing you have to click next, next, next like 1,000 times to install it? I was pushing for that. I was like, we need to have the wizard with the button, and you have to click a lot on the button. But Travis, he was hard. He's like, no, I don't believe in the button, Tobias. So finally, Travis won. So we decided let's go with a native Linux experience. So that was a key thing. Like SQL Server should be an absolutely great Linux app. It should look like other Linux apps. It should be configured like other Linux apps, and so on. And that's actually something we've gotten lots of really, really good feedback from kind of die-hard Linux fans that haven't spent any time with SQL Server. They're like, wow, installing this is as easy as other software. Way, way better than the other pretend database company.
Oracle.
Yeah, that one.
Yeah. Or as I'd like to start calling them, Boracle. All right. So should we take a look at what it looks like to install SQL Server on Linux? I think we should. So this is our documentation. It's up at docs.microsoft.com. Every Linux installation begins with documentation. You go find the documentation on how to install something, and you just start copying the commands out and putting them into your terminal. So here we're going to curl down the key to get access to the registry. We just paste that into here and run it. Done. Okay, next step, we're going to configure.
So what did that actually do?
This gives us the access to the package repository at packages.microsoft.com.
Do I need to have some sort of license or?
No licenses. Just very easy. You just copy paste. It's hard.
Yeah. So there's no kind of logging in or anything like this to get to the packages?
Nope. No volume licensing service center.
No, we still have that.
Well, we have, but for Windows.
Yes.
But not for Linux. We want to make it easy for Linux. So now that we're done with that.
We want to make it easy for Windows too.
Yeah. Eventually. We'll get there. Okay, we're almost done, and one more command to actually install SQL Server.
So you added our repo to the
repo config, right? Just one command, pulls down the repo configuration file, puts it in the right place, and now I can install any package off of there. And whenever I want to upgrade, like on Monday next week, I just already have the package repository in my config, and I can just apt-get install that particular package. So very easy, right? And once we get this installed here, then I will be able to configure it.
So apt-get install, or did you do, is this yum, is this rel?
This is Ubuntu, so I did apt-get install. Yep.
So on rel you do yum install. So that just downloads the bits from our package repository and lays the bits out on disk.
Exactly. Now this is a little bit different than how you do things on Windows, right? Because on Windows you download the setup.exe, and then you install and configure it at the same time. With Linux, you install it first and then you configure it, right? So it's a little bit different process for how you get everything done there. Okay, so now we've already got it installed. So now what we need to do is we need to go in and configure it. So here we've got the next command, which is to run the MS SQL conf setup command.
So is the service running now?
Yes. No, it is not actually running yet. Okay, so we're going to be prompted to accept the license terms, of course. Got to make the lawyers happy. And here it's going to prompt me for my edition. I think that I will choose Enterprise Edition. And then I will put in my password.
And don't you have to enter a license key?
No, actually. We wanted to make this really easy for people to get started and install. And we don't prompt them for a license key when you're installing SQL Server on Linux. I think that's just a beautiful thing. What do you guys think? All right. So obviously this means that everybody's on the honor system. you know, it does say up here paid, right? So you guys need to make sure you got your licensing in place. But if you have already taken care of that, you don't have to go and even find the product key somewhere and have to go and enter that. Okay, now that I've got everything configured here,
and you noticed I could install Express Edition and Developer Edition all the same way.
One package, any edition, and you can change editions after you're installed too. So one of the things that you notice here is that this kind of feels a little bit almost like a wizard. So you sort of got what you wanted, Tobias, because I can click next sort of here, because I have to like answer a few questions. But of course, in the Linux world, everybody wants to do things in a super automated, scripted way. So that's where we can use MS SQL Conf to actually configure things ahead of time before we do the installation. So we can script out the installation and provide all of those setup parameters. And we can either use MS SQL Conf in a script to set all the parameters, like accepting the license agreement and so on. Or I can have an mssql.conf file that has all the settings in it, and I just place the file first before I run the setup command. Or I can set everything through environment variables. So any of those options work to have a fully automated installation of SQL Server on Linux in a way that Linux administrators expect. So going back to what Tobias was talking about as a principle, is we wanted to have the user experience feel like something that was native to Linux. And so by having a package-based installation, having the ability to have a scripted installation with environment variables and a configuration file is exactly what Linux administrators want, to be able to have an easy installation and configuration experience for SQL Server on Linux. So there you go. What do you guys think? Pretty easy, right? So hit 5.
Cool. So let's just talk a little bit about how we did this and why it works. How many of you guys have heard kind of the story about SQL PAL and how SQL Server on Linux came to be? Show of hands.
What?
Oh, okay. Only a few.
Whoa. Okay. You got to hear this story. It's so good.
Well, thank you for expectations.
Here, let me start a fire so we can have a little fire story time here with Tobias.
So this is actually kind of a yearly thing in the database systems team, is maybe we should have SQL Server on something other than Windows, right? And the problem you run into, independent of, like, if you look at the interwebs, there's lots of thoughts like Microsoft already had it on Linux sitting there and just didn't want to release it. Or, Sybase was already on Unix, so that should be just, ported right over and it will just work. And that's absolutely not the case. Right? The issue is that SQL Server, we have a kind of a platform abstraction layer called SQL OS, right? That basically manages system calls. So like create threads, do I/O, or doesn't always do that, but and memory management and things like this. But the rest of SQL Server bleeds into Win32 like there is no tomorrow. Right? We use lots and lots of Windows stuff. Why? Because we only ran on Windows, and if someone already built, for example, an XML engine, why would we build our own XML engine versus just using the one that Windows built, like SQL XML? So that's a great example of, if you just ported kind of SQL OS and the base engine, if you will, it would have basically no features, right? And that's when you start getting into the problem, okay, so if I need to port SQL Server to Linux, I need to port more or less Windows to Linux, right? Or all of the dependencies that SQL Server has. And this becomes this huge, huge project. So every time we look at this, we conclude that we'll spend like 2 years before we even can compile, right? And then who knows, what performance, all of these things, then it's like optimizing, and then people are checking in new features meanwhile, and you need to try to merge and all of this. It becomes a very, very complex and extremely boring software project. Like, trying to get developers to even want to work on that is going to be very hard.
That would be developer abuse, basically.
Yes. Yeah. Which I'm not completely against, but
from time to time.
From time to time. But so when we kicked off this project, we actually, the guy who built or kind of architected SQL OS back in for the 2005 release, Slava Ox, we discussed with him if he wanted to come back to SQL and work on this. And he was like, no, you guys are crazy. Like, we should not do this. This is stupid. And then he was going back to his cave when he started thinking, well, maybe. Because he left SQL to go to another project called Midori at Microsoft. This was a new kind of operating system that a bunch of engineers were building, the managed operating system. And they built this operating system And you know when you have a new operating system, what is it that you typically don't have that is really, really good to have? Applications, yeah, software, that'd be good, right? So they had this Midori beautiful operating system, nothing works, right? So they're like, this is a problem. And then there was this other project at Microsoft called Drawbridge to build very, very dense VMs so that for Azure, so that you could run like hundreds or thousands of VMs on the same machine. And that project was basically, instead of running VMs, which virtualizes a processor, it virtualized just the NT kernel. So basically, they had another Windows kernel on top of the Windows kernel and doing the mapping between the kernels. And then you could run this very, very densely. And they developed this technique to make this secure. So then the Midori guys were like, this is interesting. If they can run the Windows kernel on top of the Windows kernel, maybe we could run the Windows kernel on top of the Midori kernel. So they basically worked on that and got that working. Another team at Microsoft Research also said the same thing. Well, if I can run the Windows kernel on top of the Windows kernel, then maybe I could run the Windows kernel on top of the Linux kernel. And they did the work to basically map this together. And the interesting thing here, why this works is, there's thousands and thousands of calls, but they basically did the work to notice that there is only about 40 syscalls that most applications need. Okay? And the problem that Drawbridge ran into is this project wouldn't just work with everything. Right? You had to tweak the app to make it work. If it made any other kind of uses of any other things, then you had to change the app. But then what kind of Slava realized is, this is interesting because if we own the app, SQL Server, right, we can tweak SQL Server to make sure that we only use these ABIs, these syscalls. And then we could run the SQL binaries on top of the Windows kernel mapped to the Linux kernel on Linux. Okay. So that's basically what we did. And it was very interesting. When Slava started, first he just booted up the Drawbridge thing on Linux and got Reversi, the game, running. And then basically 1 month later, so kind of 2 months in, we had SQL Server booted up on Linux. It was very, very cool. And you should have seen the faces of kind of the leadership when we showed it. They're like, what? It's working, it's running. It was crashing all the time, but at least we kind of got it started. Yeah, there was a lot of prep for every demo and crossing fingers and all of this. But then basically we said, okay, this is interesting because this means we run the Windows binaries, right, of SQL Server on Linux, which means we don't have to recompile. And we just make sure to bring the libraries that we need from Windows over, okay, and add it to our packages. And then it's all about optimizing this platform abstraction layer that we call the SQL PAL. So if you look at this picture to the right, you have SQL Server, right? And as I said, we call into lots of Win32 libraries. The interesting thing is if that Win32 library doesn't call into the operating system, doesn't make a syscall, it's just executing Intel instructions. Then there's zero difference if you do that on Windows, Linux, or something else. It's just, it's just Intel instructions, right? So those things will run exactly the same. Anytime, however, we make a syscall, right, then we have to make sure that it's optimized. And lucky we don't make much syscalls, right? We create threads on boot. We allocate memory in large chunks. It's really I/O, right? Network I/O and disk I/O that we spend time on. So that's been a huge part of this project has been optimizing the I/O stack so that we call directly, don't go through kind of the Windows layer, and that's how we got the performance. And the other thing that's been a huge part of this project, probably the biggest part, like 70, 80%, is getting all of our tests. Like we have hundreds of thousands of tests to run against SQL Server on Linux. And I think you'll talk a little bit about how...
Not in this session.
Okay, but we have a Kubernetes cluster and run these tests actually using Kubernetes, which is pretty interesting.
We spin up 700 containers per test run and run all those hundreds of thousands of tests against it. It's pretty awesome.
Yeah. So that's roughly how we did it. And about performance...
So before we go on to performance...
Before we go on to performance...
Yes. A couple points here. One is that because of the way that we did this, every time we introduce a new feature to SQL Server, like SQL Graph, which we'll cover later, it just shows up on both Windows and Linux at the same time, right? So That's just a beautiful thing. We have developers that build SQL Graph, and they develop with using SQL Server on Windows, but it just works on SQL Server on Linux. And the second thing here to point out on this chart is that we put the database engine and integration services on top of the platform abstraction layer, and that's available in SQL Server 2017. Some of the other SQL Server roles, like analysis services and reporting services, have not been brought over to run on top of the SQL PAL yet, and they are not available on SQL Server on Linux yet, right? It might come at some point in the future based on customer demand for that, but for now, it's just the DB engine and integration services.
Do exactly all features work, Travis?
We will get to some few cases, but within the database engine, it's a very high percentage. Should we enumerate some of those that are not?
Yeah, I think the general thing is the things that may not, or that don't work is either they fall into kind of two categories. Either we didn't think they made sense on Linux, and it's really only one, and we're actually looking at that because we have some customer feedback saying that they would like this, which is file table, right? Because file table is a table showing up as a folder, a Win32 folder, which didn't really make sense from a Linux perspective. What else?
So we have the agent working on Linux, but not all of the agents. So one of the big areas that we're working on right now, but it's not there in SQL 2017, is replication. So that's not there yet, but it will be here pretty soon. And then StretchDB is not there, and
then the machine learning thing is not there yet.
Right.
So R and Python will show a demo of Python is not on Linux yet.
Right.
And that is absolutely coming. It's just time, because we need to, the thing that's interesting with machine learning services is that we run, you can add any open source or proprietary R or Python packages and run them. The problem here now is that we run this Windows thing on Linux, so we could make it work fairly easily to add Windows packages in, right? But that would be a little bit weird on Linux. You would expect to be able to run the Linux R packages and Linux Python packages. So that's the work that we're going through right now, so that we basically hook up SQL Server on Linux with R and Python on Linux.
But pretty much everything else inside of the database engine, whether it's column store or in-memory or partitioning or all the security features, all of that stuff just
availability
works.
groups,
Yep.
all of these things, hackathon, this, that, and the other thing.
Yep.
So performance, this was actually first that we did. We released this benchmark, what was it, February?
May.
Mm-hmm.
May.
So quite a few months before GA, where we did the first TPC, public TPC benchmark for SQL Server 2017, and we did it on Linux. So here you can see on exactly the same hardware, SQL Server 2017 on Linux versus SQL Server 2016 on Windows. And as you can see, SQL Server on Linux is about, or 2017 is about 5% faster. This is not a statement about Linux being faster than Windows, by the way. It's just optimizations and so on in SQL Server 2017 gave the run this boost. But it shows that SQL Server on Linux definitely isn't slower, right? So
all the Linux people, of course, they latched onto this like, I knew Linux was faster. But it's not actually the case. It's really more that SQL Server 2017 is faster than SQL Server 2016. And just within our lab testing, the performance of SQL Server on Linux and SQL Server on Windows is basically the same, right? So it depends
you
on
will
which benchmark.
you will notice differences because there's different operating systems, but it's kind of within the error margin.
Yep.
Cool. So Travis,
all right.
Why don't you show us a little bit more about this perf and scale? Can you actually run SQL Server on Linux on like half-decent machinery, or it does only run on your MacBook?
We wanted to figure that out, actually. So we found this Superdome that was just sitting over in the corner of our lab. It wasn't being used. It was just, I don't know, collecting dust or something. So we said, hey, what happens if we put SQL Server on RHEL on that Superdome and ran a gigantic query against it? What would happen? So here's, I'm SSH'd into that machine. This machine has 12 terabytes of RAM. That's a whole lot of numbers in KBs, okay? 12 terabytes of RAM. And let's also look at the number of CPUs. Here we've got 480 CPUs. So that's 240 cores with hyper-threading.
That's cheating. Hyper-threading?
I know, 400. It's funny, the devs the other day were like, like joking around with me. They're like, oh, you don't even know what hyperthreading is. I was like, dude, whatever. Okay. Okay, so now let's do something fun here. Let's run htop, okay? So here's our cores. They're sitting here doing nothing. And now let's run a big, gigantic query against this database.
It doesn't look very big.
It's tiny, but look at all these sums and averages in this query, right? So we're doing a lot of calculations. This is over a 30 terabyte database that we have. And we will process about 250 billion calculations on this database. And look what these cores are doing.
Oh, that's good.
We are pegging all of these 480 cores. And we finished that query in 23 seconds. 250 billion lines. What do you guys think?
Can you run it again?
Huh?
Can you run it again and show htop again? So it's interesting, if you switch over to a little bit what I was talking about. Let's see if it boots up here. So you notice this is all green. It means we're spending all of the CPU time in user mode, right? We're not, if it's red, we're waiting somehow for the operating system. So this is the most beautiful thing you can see if you do benchmarking. It's CPU, which is the fastest thing in the machine, pegged, green in htop, which is all in user mode.
Awesome.
I would like one of those machines.
Yeah. It'd be great for Minecraft.
Bitcoin.
Oh, Bitcoin mining, right.
Aha.
All right, so a lot of the things that we did just worked because of the SQL platform abstraction layer. But some things we had to kind of do a little bit differently because we were on Linux. So one of those things was high availability. On Windows, we depend on Windows Server cluster services for managing a cluster and doing the automatic failover, right? Obviously, Windows Server cluster services doesn't exist on Linux. We thought about putting Windows Server cluster services inside of the SQL PAL, but that just seemed weird. And going back to the principle that we had of making things feel native Linux.
And not weird.
And not weird. We decided not to do that. And so we went around and talked to our new friends at Red Hat and Canonical and SUSE and said, hey, what do people typically use for a cluster manager in the Linux world? And they said, there's this open source project called Pacemaker. That's sort of the de facto standard for cluster management in Linux. So, okay, perfect, let's go use that. So we built our HA capabilities on top of Pacemaker. That's sort of the reference implementation of HA for SQL Server on Linux. But we did HA a little bit differently in SQL Server on Linux. We actually kind of flipped it around a bit to where there's not such a tight dependency on the cluster manager in Linux like we have on Windows. So other cluster management technologies can be plugged into SQL Server on Linux. If you wanted to use something like Zookeeper or you had a hardware-based solution from a hardware vendor that you wanted to use, it can actually plug right into the way that we implemented HA for SQL Server on Linux. In the Linux world, there's oftentimes lots of different ways to do things. Pacemaker is just one of them. It's sort of our reference implementation of it, and we've documented how we do that, and that's available up on open source on terms of how you can do that. Now, there's a couple other things we've done in SQL Server 2017 around high availability. One of them is that we now have read scale out without a cluster. So if you want to just have read scale out, you don't care about high availability and automatically failing over, you can now set up an always on availability group without a cluster underneath it. You can do that on Windows or on Linux. Right?
What's read scale out?
Oh, read scale out is this beautiful thing. You can have a primary node, which is where you're writing all of your data to, and then you can have additional nodes within your always on availability group that all the data is being replicated to. And then you can have applications, when they connect to the primary, indicate that their intent is to read data. And the primary will redirect them to one of those other nodes that's in the always on availability group that's there for read scale out, and they can do the reads off of those other nodes. This is also beneficial for scenarios like where maybe you want to offload some of your processing of your data or backups or things like that, or reporting and analytics where it's just reading. You can offload all of that to the read scale out instead of having that hit the primary node where you're writing the data.
How many of these read replicas can we have these days?
Oh, so many. You can have, I think it's 8 per cluster, and then you can have availability groups which are kind of chained together, and you can have up to 8 levels of that. So, no, not 8 levels? 2 levels.
No,
oh, that's right. Two levels.
No, you're not allowed to. We haven't, Mihaela haven't tested everything, so we can have hundreds.
Hundreds.
But we're not allowed to say that.
Yeah. We like to make Mihaela feel uncomfortable about things. It's really fun.
Yeah, she owns availability groups.
Okay, so let's take a look at a demo of high availability now. Okay, so the first thing I want to show you is our Active Directory authentication. So this is another thing where we kind of had to do things slightly differently, but we wanted to feel native. This is actually sort of the reverse, where we wanted it to feel native. It's used to using Active Directory, even though the SQL Server instance is running on Linux. So you can join a Linux machine to a Active Directory domain, and if you do that, the SQL Server instance that runs on top of it can be connected to using Active Directory identities. So here I'm going to connect to a database engine, and I'm going to connect using these Windows authentication credentials here, just like I would to a SQL Server instance on Windows. I can just connect to it immediately like that, right? Exact same experience, nothing different. So now let's go in here and let's take a look at the Always On Availability Group dashboard and see what's going on here. So we have one availability group defined on this machine, and you can see that we have a 3-node cluster here, rel 1, 2, and 3. And now I've got a simple application that when I run it, just connects to the cluster IP address and gets routed to whatever the primary node is, in this case, rel 1, and it just outputs the name of the computer that I'm connected to. Now, over here, I'm going to kill rel 1. I'm going to reboot it. So you can see that I lost my connection to that in the SSH window here.
Could you have a smaller font, do you think, in that window?
No, I can't. It's very small. Okay, and over here,
I was being ironic.
I know. Over here, in rel 2, in my SSH window, we can connect to there, and we can run CRM-mon so we can keep an eye on the cluster. And we can see that rel 1 is now dropped out of the cluster, and pretty soon here we'll see that rel 2 will connect back. So while we're waiting on the app to reconnect, I want to tell you about one important thing that's going to be coming here in the first cumulative update to SQL Server 2017, which will be coming out about 2 to 3 weeks after the GA release. And that is that on Windows, we have this option to have a file share witness for your cluster. So you don't have to have more than like 2 instances of SQL Server. You can just have 2 plus a file share witness. On Linux, we don't have that same capability with Pacemaker. So we're introducing an option where customers can have a SQL Server Express instance that's there as a witness-only replica. So you don't have to pay for a SQL Server Edition license, but it can be used as part of your always-on availability group cluster so that you have a third node within your cluster that can help you avoid the split brain type of situation, and you can actually...
This failover seems very fast, I must say.
Yes, it does take about a minute. So it should be coming back here pretty soon. It's always hard to time this. Come on.
We will wait. Is it over here?
There it's coming back. It's probably coming back online now. You can see over here in CRM-mon that rel 1 is back in here. Should have failed over to rel 2 though.
Travis.
This is not good. Should not have.
But this is not SQL Server's fault. This is Travis's fault.
Yes.
Let's be clear here.
My fault.
This is DBA. This what is it? Shit behind the keyboard or whatever.
Well,
Should we?
I'll keep an eye on this. Why don't we do your HA demo and let's see if you fare better.
Okay, maybe I shouldn't have made fun of you.
Yeah, see, you think you're so hot. We'll see if your HA demo works.
Okay, is this 6 or 9? Let's see here. Aha! So, we are going to try something that also Miela loves when I demo, which is, so we said that we had this compatibility thing between SQL Server and Windows and Linux. We also support you taking a backup from Windows and just restoring it on Linux, or detaching a database on Windows, attaching it on Linux, back and forth. This means, well, we're poking around with this. This meant, but then availability groups should really work, between Windows and Linux. And there were a lot of protests in the beginning in the team. We're like, this seems actually like an interesting scenario if someone is moving from Windows to Linux or Linux to Windows, and they want to do this as smoothly as possible. We actually had a few customers now that talk to us that are, have to have systems that are very, very that can handle kind of any type of disaster. So they said, hey, it's interesting if we can have a system that runs both on Windows and Linux, because if there is a problem on either operating system, we can just fail to the other operating system for like very, very serious software. So we said, okay, let's see if we can make that happen. So I'm going to try to show a hybrid availability group between a Windows machine and a Linux machine. So I'm connected here on my primary is going to be on a Linux machine. So we can run at that version here and just see I'm running Developer Edition on Linux on Ubuntu 16.04 here.
I failed over, by the way.
Okay, what's your thing? 8.
There you go.
Woohoo! Oh my God.
It may not be fast, but it is reliable.
Huh. Okay, so let's see if we can set this up. So first of all, I'll just check I have only the system database on this machine. And I already created a master encryption key, which I need to use for key management. So this AG setup, I'm going to use certificates for authentication. So I create a certificate on the primary machine, on my Linux machine, and then I'll copy that certificate to the secondary so that I can hook them up. We're working on supporting Active Directory authentication as well for this scenario. So I'll create the certificate here, and then I'll back up the certificate file, or the certificate out to the 2 files under var opt MSQL data, which is where we keep the databases by default. And then let's move over to my secondary and just check. This you see SQL Server 2017. Whoa, I'm connected to the wrong one here. Also on Linux. There we go. Running on Windows Server 2016 in this case. And we can also see here I only have the system databases. Here I also created the master encryption key. And now what I need to do is create the login that's going to be used and the user that's going to be connected to that login. This is just for authentication. And then we're going to try to create the certificate. But I have to get the certificate now from the Linux machine over to the Windows machine. So we can see here I'm on the Linux machine. So you can see here, these are the certificate files, DBM, certificate SIR, and PVK. So first, let me just copy those over to my home directory. Doobie-doo. And that might have been not the right thing. And then I need to change ownership of these files to me. Okay, so now I have them in my home directory, just to make it easier for me to copy it from the Windows machine. So then let's open the Windows machine, and I just have a command prompt open here, and I'm going to use putty, so secure copy to copy over the file. So Tobias T at, what's my machine called? There we go. And the files are in home, Tobias T, DBM star. There we go. So now I have the files, the certificate files copied over to my Windows machine. And so then let's just move them into the right path. There we go. And now I'll run the create certificate. So you can see there I give the path into the data directory. Okay, so now I have the certificate created from my Linux machine. And then let's go back and continue here. So I'll create the login and user also on the Linux machine. I'll create the AG endpoint that SQL Server will listen to for the availability replication. And then I'll start the endpoint and grant connect to this DM underscore login. So that's where I say, hey, this login, which is connected to that certificate, is allowed to connect to this endpoint. Okay? And then I'll create an availability group. And in this case, I only have one replica, which is my Linux machine. And here, this is an interesting new feature that was in SQL Server 2016, but you may not have seen it. which is automatic seeding. Meaning that before, I don't know if you've set up availability groups in 2012 or 2014, you create it, but then you have to back up the database, restore it on the other end, backup log, restore log, and then you can set up the replication. With 2016, we have automatic seeding, so you don't have to do that, which you'll see here, which is pretty cool. So I'll create the availability group. And then I create what's called a distributed availability group. I didn't need to do this step. I could have created just a local availability group, but this is an interesting feature to point out. So, typically when you create an AG, you have a primary and up to 7 secondaries, or 8, Mihela? How many secondaries? 7 or 8? Yes? 8. But if I want to, the issue here is if I want to do this daisy chaining, right, then I want to say, well, and one of these replicas is actually a separate cluster. And that's what I use distributed availability groups for. So this is where I say I have one local availability group, and I connect 2 availability groups together, and then on the other side I can now create, it's now a separate cluster. I can have up to 8 replicas there, do this again, and do 8 replicas again, and so on. And the replication, by the way, we've done a lot of enhancements in both 2016 and 2017. So the overhead of replication on the CPU is marginal. It's less than 5%. And we can push north of a gigabyte a second through availability groups replications. It's very, very efficient. So I'll create this distributed availability group. So here I see I have the one I have on my Linux machine and the one I will have on my Windows machine. And then I allow the availability group to create databases. Okay, so there we have kind of the setup. And obviously you could create a stored procedure or use the wizard to create it. And then on the secondary, let's do the same thing. So we'll create the endpoint there. Start the endpoint. Grant connect. Create the availability group on the Windows side. Create the distributed availability group. And allow this availability group to create databases. Okay. So now we have the whole connection set up between Windows and Linux. So now let's try and create the database on the Linux side. So create database Tobias. And then let's make sure it's in full recovery model. And then I have to do an initial backup, but that backup is just to make sure there are no bulk logged or non-logged operations in the database. So backup database Tobias T to disk equals null. And then we can now just kind of set up the replication. So that's alter availability group, which is called myAG, I think. Add database Tobias T. Wonka. So we can see I have the Tobias T database over here. And then let's just go look on the other side. Woohoo! Tobias T showed up on my Windows machine. So I didn't have to do anything more than this. That's,
That's pretty mind-blowing that you're like replicating between Linux and Windows.
And we could, just to show now how easy it is, right? We just started supporting Travis databases. This has been a big implementation though. So we can run this, and then Travis shows up. And then obviously, if you start using the databases, so if I go into Tobias T, Travis can be a table as well. Yeah. Insert Travis, a 1. And then on this side, let's select star from Tobias, Travis, and, Tobias T, my bad. And there we go.
Wow.
So it's pretty cool, right? And this is between Linux and, woo! But hopefully you kind of get a sense of how serious we are about both interoperability and the experience on Windows and Linux. Because obviously the Linux experience is for Linux sysadmins, but you also notice if I'm a SQL DBA and the SQL Server happens to be on Windows, I still use Management Studio. It's exact same T-SQL, same features, and so on. So you're kind of right at home, right?
Now we can go back to the deck.
Back to the, oh, sorry.
Yeah, 5.
So let's talk a little bit about CI/CD, which is an interesting topic. And this is kind of a traditional CI/CD pipeline, so continuous integration to continuous deployment, where someone pushes code, kicks off an automatic build, kicks off automatic tests, and deploys. But for database people, it's actually typically a bit different of a pipeline, all right? So from a data perspective, it really doesn't start with development. It's not for all scenarios, but for many scenarios, it actually starts with production, okay? So you have production, you have development, and then you have some sort of pre-production environment in between. So let's say that we're kicking off a new sprint. What needs to happen? There we go. So, and also, if you notice at the bottom here, the difference between production, pre-production, and development is on the production, pre-production side, we have non-sanitized, we have production data, right? Actual customer names and so on. Whereas developers developing the application should obviously work on sanitized data, right? Anonymized somehow. So we kick off a new sprint. The first thing you need is a dev environment, right? So there's a couple of different models for developers. Either you have a shared server, right, that lots of people use together, or everyone has their own local database. And that's really the easier development perspective if you have everything locally. About 75% of developers have kind of the whole stack running locally on their dev machine. So what we want to do is we want to create a dev environment for this, for our developers. And Docker containers are a really, really good place to do this. Okay, so the first thing you would do is back up a database take a backup from production, right? That backup, and then restore that backup into a Docker container, okay, into a SQL Server running inside a Docker container. Then you can commit that container. Now you have a perfect system set up to run pre-production tests, right? Because it's the actual production data. After this, you can sanitize the data, right? And then you can create another Docker container based on that. That's a good, larger, potentially, right, larger dev environment. That's good for maybe running perf tests and so on. Then you could go and delete a bunch of data and shrink the image to create a smaller dev image, which would be good for kind of unit tests and maybe for most developers to work on. So I can go and create all of these images. Now, when a developer starts their cycle, they just do a Docker pull of this image, of their DB, you know, their dev small image, dev big image, or whatever, and they can start developing, right? They have everything they need for that sprint. And once they push code, you know, we kick off continuous integration tests. They probably pull down the integration pipeline, just pulls down the SQL Server image for the unit test, the small one, runs the tests. Maybe you have weekly tests or daily runs that do performance runs. These would probably pull down the big image, right? And then once you're ready with the sprint, you're ready to kind of push out to production, that's when you use the pre-production image. And probably now, this is when you're creating the new image for the next sprint. So you use that image that you just created to run your pre-production tests, right? User acceptance tests and so on. And if there is a problem, you go back and fix it, and otherwise you deploy, right? I'm not saying that this is perfect for everyone, but it's actually a very, very interesting cycle. And we want to kind of show you why using containers for development makes a lot of sense for SQL Server. And one of the biggest issues actually that people face with SQL Server with development is that SQL Server itself, it's really a component of the app, right? You want to rev it, you want to get new versions and so on into your app, but that's not how people treat it, right? They have treated more like a monolithic server application. So with a container model, you can actually start treating SQL Server much more like a component of your app than a big monolithic thing that you install every once in a while. So when you go in here, start the sprint, you'll obviously go and pull in dependencies, like get the latest PDF generator library or whatever you're using. Well, at the same time, you could also pull in the latest SQL Server update. Be it a major version, a cumulative update, or whatnot. And now the next sprint will run on that SQL Server version. So let's take a look at how this works.
So while you're getting set up with that, kind of one more point on this is that it's really key to kind of think about that you want to keep up with the latest versions of SQL Server so you don't fall behind. How many of you guys have like SQL Server 2005 in production still? A lot of people, right? Okay, so how do you avoid that, right? One way to avoid that is to start adopting these CI/CD pipelines, where as part of your continuous integration cycle, you're pulling the latest versions of SQL Server, so you're always staying up to date. And one of the best things about using container images to do all of this is that you can run all of your dev environments on one container image. You can take that exact same container image, put it into your pre-production and your testing environments, and run all of your tests there on that same exact image. And then when you deploy it into production, you have a high degree of confidence that it will just work because it's the exact same container image that you've been using all throughout your dev test cycle. So this is kind of a new way of thinking about having SQL Server just be another dependency to your application. And that way you can kind of stay always up to date.
Okay, so first let me give you just a brief example of this. So this is on GitHub, our JDBC driver, which is open source since November last year. And if we scroll down, we can see here that we run a CI environment here. So we have AppVeyor for Windows tests and Travis CI for Linux tests.
That's the best one.
That's the... And then if I click that one, I can see the latest run. And if I scroll down here, here we go, and make it a little bit bigger. Here you can see it did Docker pull Microsoft -MSC or /MS SQL Server or MS SQL Server Linux. And that took 32 or almost 33 seconds. So that went to GitHub, or sorry, Docker Hub, pulled down our public official image, which you also can use with any kind of license of SQL Server, the license that you have. And then it starts that image, checks that the image is running, and then it starts running the tests using Maven. So this just automatically pulls down the latest SQL Server version and runs through the test. That's a full install. So let's try this. So here is just a file I set up, or a file I prepared for running this test. So let's first just do Docker pull to pull down the official image. Now this one, as you can see, I already pulled it down, so we don't have to wait for the download. So it's there, and I can check in Docker images that we see that we have the image there. Okay. So in Docker, if you haven't used it, an image is something that you can kind of create containers that run from. So a container is an instance of an image that's running. So I have that. So then let's start SQL Server. So here we say, start the SQL Server container, or create a container based on the SQL Server image. I'm going to call it Sanitation Station. And then we require 2 parameters to be passed. So one is to accept the license agreement, and one is to set the SA password for this image. So I'll run that. We can do Docker PS to see that it's there. So it started. And here I changed it because I already have SQL Server installed. This Docker image is listening on port 10433 rather than 1433. And then I can Docker exec into this image. So now I'm inside the image, right? And we can just look if we have SQL Server installed. Far up. Yeah. There we go. And so there we can see that the database files are there. Okay? So that's, and again, you don't need any passwords or anything to get to this. It will just work on your machine if you have Docker installed. So next step is I want to go and create these environments. So first of all, I need to restore my production database. And show you the script. So regular restore command, the only thing I'm doing is I'm restoring it from, actually it's in Azure file storage. And then I have to do with move, because this backup is actually from a SQL Server 2012 instance. So we'll have to run through the upgrade steps. But then also by default, it will place it in C: program files or D: wherever you had it on Windows. And obviously those paths don't work on Linux. You have to just redirect the paths using move. So I'll run that.
pretty awesome to think about that you're taking a database from SQL Server 2012 on Windows and restoring on SQL Server 2017 on Linux.
Yeah, it's pretty cool.
You just
Okay.
fast forward right through that.
So now we have this running, and we can connect. All right, I'll do that later. Now, what I just did is I created an image. I now have a container that's perfect for running my pre-production tests in my kind of simple scenario. So then I can go and say, hey, let's Docker commit this into db pre-prod latest. So now it creates an image that is exactly what I need. It contains now my restored database as well, and later I could go push that to a repository. So we can do Docker images, just see that now I have two images. We have SQL Server Linux image, and then we have this db pre-prod. And it's very nice with Docker because the images are based on each other. So it doesn't store, the whatever 1.5 gigabytes twice, right? It only stores a diff between them. And then after this, we can go and just run a query to see what's going on in the database. So this query just goes to the employees table and select top, so we see the data is there. And then I need to now sanitize my data so I can give it to my developers. And here I have my sanitation script. I only have one table. It's the person table, and we do use Norwegian encryption on this, which is reverse the strings. I'm Swedish, so there is this thing between Sweden and Norway.
Swedish encryption is too lower, though.
Yeah, very funny. Very funny. Let me not get too American encryption.
We don't bother encrypting things.
Experience. There we go. So we updated the 1 million or so rows in the in the table. We have lots of employees in our company. And then if I run the same query again, you'll see that they have been encrypted using this Norwegian encryption. Right? Cool, so now I have an image that's perfect for my devs, because they can't see now the production data, unless they're geniuses. Right, something. I did some copy pasting before, so. Anyways, so now I go and commit, and I can go down the line and continue creating these images, and then later, and we have the links to all of the demos, by the way, so you can go to GitHub and find them. But later, after I created the images, depending on the sizes, I might want to shrink them, so you can do Docker export here to shrink the data, to basically flatten these images, which makes it not deltas anymore. So having all of them on disk will take up more space, but if you want just one developer to pull down one image, it might be smaller, right? And then after this, I can go and build the image and basically push it to the registry. And then my developers can now go just Docker pull, and they have the perfect data dev environment to start working against. So now Travis is going to show us a bit of the next steps.
Right, so I'm going to put my developer hat on, working on this application. And all I want to do as a developer is git clone the project and then immediately start being able to test it and develop on it, right? So as part of this project, we have a Docker Compose YAML file here. And this describes how we can fire up a number of different containers together to start the application. You can see here that we have a web container, which is an ASP.NET Core application, and a DB container, which is based on the image that Tobias just built and pushed up to the registry. And if you look up here in Azure, we have the image posted up to an Azure container registry here. So db dev small, right? Now, if I just go to my command line and run docker compose up, this will start up the db container and the web container simultaneously. And I can then immediately start testing out the application. I can just go to a browser, localhost 8000. And now it's up. Okay, and we have the Contessa University application up and running. And you can see that here, if we go to the Students tab, that we have the students with the Norwegian encryption, right? So this is a very easy way for developers to get started with something. They don't have to go through some complex installation process to install a bunch of things on their machines. They literally just git clone the project, Docker Compose up, and they have a running application with a sanitized small test DB that came from production. So they're actually using the production data, but it's sanitized, right? And once I've got this, now I can start to push this application up into a Kubernetes cluster, for example. So here I've got a Helm chart, which is defined, that allows me to define the database container as a pod and the web container as a pod as well. And then we can start to push these up into a Kubernetes cluster. So to push a Helm chart up into a Kubernetes cluster, you use Helm as the command line utility. And this will go out and it will push up the pods to the Kubernetes cluster.
If you haven't spent time with kind of containers and all of the different platforms before, it can be a little bit intimidating in the beginning. There's so many new names for everything. It's really not that bad. So like if you spend some time on it, you'll get it. And then like once you just get through kind of the initial step, it's super, super useful. So I would recommend spending some time if you haven't on containers, container platforms, and actually trying them out a little bit. Because that's one thing we strongly believe in is kind of like VMs, came and no one thought databases would be on virtual machines. You'd be stupid to do that, right? Now most databases in the world run on VMs. We strongly believe the same thing will happen with containers. So it's more immature for production workloads still, but we believe production will also head that way. So that's good investment of time if you haven't done it to spend.
Right, so I just ran helm install Contoso U up here. And now if I switch over to my Kubernetes dashboard, I can see that these pods are now deploying out into my cluster. As I can pop open the pod and I can see that I have my DB container and my web container. So it's a very easy way for me to go from a development environment on my machine and push it up to a test environment or even to production on a Kubernetes cluster. And this way, I'm running the exact same image in my dev environment as I am in test and production.
Cool. So, Travis, can you tell us a little bit about Graph?
Yes. So, one of the awesome new features in SQL Server 2017 is graph capabilities. So, typically, people today, they would store their graph data in something like a Neo4j database, some other database. I was talking to a customer the other day, like he has a weekly job where he exports all of his data out of his relational DB and loads it up into his graph DB so that he can use it in a graph type scenario. So in SQL Server 2017, we want to make that easier for people, so you have the ability to store graph data in your SQL Server database and then query it out using graph syntax. So let's fire up a new container here in my environment.
And it's not obviously that hard to store graph data in a relational database. So the big thing that we've done is spend time adding new syntax to actually do graph queries and update the query optimizer to deal with these in a good way, right?
Come on. Okay, so fire up a new container, and I'll go into Visual Studio Code, and we'll open up.
Oh, my bad.
Okay, so now we're in Visual Studio Code. I've got a new container I've just fired up on my MacBook, and I've got just a script here we can walk through to kind of go through a graph scenario. So first, I'll connect to my local container using the Visual Studio Code add-in here. So we're doing localhost. You can see down here that I've already connected in there. And I've got a simple demo scenario here of like a factory, where I've got some factory, it's producing some products using some machines, and you can kind of imagine a graph of these different things that are being stored about this factory. So let's begin by just creating a database to store all of our data in.
Manufacturing is a very good example generally of graph queries, right? CRM is another, kind of product catalogs and so on.
Okay, now let's create some node tables. And node tables are exactly like creating any other table, except that you have this as node syntax right here. You can see that you just create integer table, and varchar, whatever the different columns are that you want on the table. And now we'll create some edge tables as well. And edge tables are just like creating any other table, except you use the as edge syntax.
And so, what's a node and an edge?
So a node is like an item, something, right? And an edge is the relationship between those two things, right? So in this case, like a machine is a node, and the relationship, and like maybe a sensor is also a node, and then the relationship between the machine and the edge, or the machine and the sensor is an edge. So now we'll insert some data into the node tables. And inserting data into node tables is just like you insert data into any other table in SQL Server. There's literally no difference. Now we'll create some edge data, and we're going to insert data in these edge tables. And here, it's basically the same, except that what we're doing here is we're inserting the node ID of one end of the edge and the node ID of the other end of the edge into these edge tables. And once we do that, we can now create some queries against that data. So here we're looking for the sensors and the machines that they're related to where there's a failure. And you can see that the only difference here is the syntax of how we do a graph query. And the graph query syntax drastically simplifies your join type of query. So instead of worrying about the difference between a left join and an inner join and that sort of thing, you can just use something that's, first of all, much more concise and easier to write, and it's also easier to read because of the graph query syntax. And one of the best things about having your graph data stored inside of SQL Server is that you get all the benefits of SQL Server as part of your graph data. So here I'm adding a clustered column store index to one of those node tables. So all of the in-memory capabilities, column store, all the security features, all of those things can apply now to your graph data as well. And then you can join it together with all of your relational data. So you can have part of it in graph data, you can have part of it in relational, and you can join it all together in one.
Cool. Thank you. The last demo we're going to show is the Python edition that we did to SQL Server 2017. So with regards to machine learning, we added in SQL Server 2016 support for R, and now in 2017 we're adding Python, and those are really the two main programming languages that data scientists use today. It's about 50-50 or so between R and Python. And we're actually working on, for the next release, to see if we can open up these APIs to make it so that third parties can add other extensions to SQL Server in kind of the same way, right? So we don't have to add all of these languages or runtimes, but others could do that as well. So anyway, if you look at the traditional kind of machine learning problem, you have data and you have decisions that you want to make, and then you based on the decision you take some sort of action. And if you look at the transition, it used to be back in the day, and probably still today, there are static reports, like reports that are in PowerPoint or printed. Then you go to kind of interactive dashboards that a human have to look at in order to make a decision. And then you get into kind of the AI or machine learning land where you have the machine do a prediction and show it to a human, or the machine does a prediction and actually tells us what to do, or actually goes and actions the decision. And this is actually very, very interesting. Now, if you haven't spent time with machine learning like Python and R, that's also very interesting. If you're kind of a SQL person, that's also a good investment of time, right? To go and learn either of those languages and go learn a little bit more about data science and the processes and so on. But in a simplified world, you basically start with someone like a data scientist that wants to create a model to do something. So a model is like a little program that you feed the data and it tells you what to do, right? It does a score. That's typically called scoring. So creating the model is called training, right? And using the model is typically called scoring or predicting. So the kind of traditional problem is you have a data scientist, they sit in R or Python, they get access to data that they need to kind of figure out which algorithm should I use, what parameters for the algorithm, and so on. Once they figure this out, they wrote a Python script or an R script, they now need to train the model. So now they need to get lots of data, because obviously the more data you have to train the model, the better the model is going to be. Or maybe not obviously, but typically, right? So that all of a sudden is a performance issue and a security compliance issue, right? You need to move the data to this kind of workstation where the data scientist is, or the server that the data scientist runs. Next, once you train the model, now you have this little program, and you need to put it into production. You need to, maybe it's typical example is fraud detection, right, for a credit card company. So it would feed the transactions transaction information in, and say, hey, this is, what's the chance of this being fraud, right, the risk of this being fraud. Now you have to look at the model and actually code up the program in something that the database or wherever you want to run the model can understand. Right? And then you obviously have to verify that whatever program you wrote in C#, C++, Java, whatever, is exactly the same as the model. So the approach that we took with SQL Server is we said, why don't we integrate and let you just run the actual R script or Python script inside the database? So the data doesn't have to move between machines and outside of compliance boundaries. You can train it locally and then score it locally. So let's take a look at what that looks like. And by the way, so this is let's skip that. Let's just show you so you've seen it. But it's a very nice graphic with a train.
I see what you did there. Train. Ah.
Okay, let's see if my computer can wake up. Oh, SharePoint? No. Okay, so we have this website that actually is very nice called, if you go to aka.ms/ml SQL Dev, we have a bunch of tutorials related to machine learning that go through exactly kind of step by step what to do. So I'm going to just use one of those. And so you can see we can choose R or Python. So I have Python here, and I want to go and do predict ski rentals. So the thought here is that we have a ski rental company, and we want to know, hey, for this date, how many skis do we think we will rent out? So I can plan appropriately, have the right level of personnel, merchandise, all of these things there. And you can see here how we go through first set up your environment, like installing SQL Server and so on, creating the ML script from a Python perspective, so working in your favorite tool with the Python script, and then deploying this machine learning script, the Python script, to SQL Server. So that's where I am at. So let me just go down here, and I'm going to use this one. Okay, there we go. And we have the sample database is also available there. So you just download that and restore it. So first of all, I have this table that contains the models. So the thought is I train a model, then I need to save this little program somewhere. And in SQL Server, we have tables, so we store the models in a table. And so the first store procedure here I have is the store procedure that trains the model. And here we have this thing that we added in SQL Server 2016 called SP execute external script. So I'm saying a language is Python, and then I just copy paste the Python script that the data scientist wrote into this. And basically, the main thing that we're doing here is, you can see down here that I'm passing a query into the Python script. And once that query is as that query is executed, it will show up inside the Python script as this data frame or data set, rental train data. And you can see here, depending on which model I want to train, if I want to use a linear regression, it's going to go and run this rxlinmod function and basically try to predict the rental count based on month, day, weekday, snow, holiday. And the data is this data set that I passed in, right? And if I want to use decision tree, thank you, then I'm going to use this, go down this path, right? So let me create this store procedure. And we have to enable this feature, so that's been enabled on the system. And then we can first just run the store procedure. So this now runs that query, passes it to Python, runs through the Python script, and it outputs the model into this model parameter, okay? Okay, so let me just run that again and actually insert the model into the table. And the first time took more time because I had to start the Python runtime the first time. And then the second one, so now I have the two models in the table. So we can see they're just saved like blobs, okay? And now the next step I want to do is I want to use the model in production. And here's interesting, I could use this SP execute external script, which is what we shipped in 2016. The downside with that store procedure is it has an overhead of a couple of 100 milliseconds, okay? The upside is it works very well for kind of batching scenarios. If you take a lot of data and pass it to it, depending also on how you call it, we can either stream through the data or we have to load everything into memory and then run it. But it works well for batch processing scenarios. If you have to get results very, very quickly, meaning I get one credit card transaction in, I can't wait a couple of 100 milliseconds. So we've added in 2017 this native T-SQL function called predict that currently works with the native Microsoft algorithms. We're going to open it up. We're doing that work to also support kind of any algorithm. And then we don't have to initiate the Python runtime or the ARP runtime. So it runs much, much faster. So you can see here, I load the model into this variable, and then I call predict, or select from predict. I give it the model. I say, hey, this is the data set, and that could be a common table expression or something like that. And then this is the output of the model. So you can see D, when I return here, D star is going to be all of my data that I inputted, and P dot star is going to return the actual predicted rental count. So in this case, the model is trying to predict how many skis or how many ski rentals would I do at this time. So run the query, and you can see it came back immediately. So this takes in the order of less than 10 milliseconds. It depends a little bit on the model. But this is very, very interesting. So now you can see it's not, especially if you're a DBA, right, or a database developer, you don't actually have to spend the time learning the Python language. You get the data scientist to run it, or to create the script, you put it into the system. Now you can train that stored procedure. I could schedule to run every day, every hour, every week, depending on how often you want to retrain the model. And then you can score using this new predict function.
Oh, 5. Okay, awesome. Thank you, Tobias. What do you guys think of having R and Python in database? Pretty sweet, right? So, hopefully you guys like seeing SQL Server on Linux. We're super excited about it. It's been very well received in the Linux community. We want to make it very easy for people to get started. So we talked to our buddies over at Red Hat. We're like all friends now, right? Everything's cool. And we actually negotiated a deal with them for you guys, where if you go with SQL Server on RHEL, with a SQL Server subscription, which is kind of a different way of getting SQL Server, you can actually get a 30% discount on SQL Server and a 30% discount on Red Hat if you go get it right now, right? And one of the best things about today, call now. One of the best things about this is that we have set up a very close relationship between our support org and Red Hat support org, so that we can easily handle any calls that come in, whether it has to do with something on the SQL Server side or with something to do on the Red Hat side. Lastly, check out some of these other sessions, and please give us your feedback on the feedback tool. We'd love to hear what your guys' thoughts are about SQL Server on Linux and SQL Server 2017. Thank you guys for coming out today.
Thank you.